Very good morning, students. Myself Praveen. I'm here with the second class of integration. The last class we have discussed uh, the types of or methods of integrals. Okay. After that, we have seen some formulas, and in that today we are going to discuss this integration of type integration of sine power mx into cos power nx dx. So I think we have not completed all methods of integrals, only one or two methods we have discussed. Today we'll discuss more one. Okay, but before that, here this is about the something we are substituting in the given integrals. Suppose here the integral is in the form of sine power mx into sine power nx dx. So we have three cases here. One, if m and n are even natural numbers, means both powers m and n are even natural numbers, and then convert higher power into higher angles. Then converting the higher power into higher angles means, suppose we have a sine power 4x here, for example sine power 4x, and here cos square x. Then we are then converting higher power into higher angles means, so this higher power we are converting into that cos square x. Okay, so we are splitting this sine power 4x, we are substituting here sine power 4x here. The second case is if at least one of m or n is odd natural number. For example, this sine power 4x and cos cube x it is. Then m is odd, put a cos x equal to t. If m is odd, means here power this 4 is odd and this is n is even, then we are substituting cos x equals to t, and vice versa. Means m is odd, sine power is odd, we are substituting cos x is equals to t. We are substituting cos x equal to t here. Okay, vice versa. It means if this power is even and this power is odd, then you put sin x is equal to, t. That vice versa here. Then last case, if m plus n is negative even integers, then put tan x is equals to t. If we have sum of these two powers is negative even integers, the sum of both powers is negative even integer, then we are taking that tan x is equal to t in this kind of integrals. Next, so these are about the substitution method only. Here we have some integrals type, that is integration of under root x minus alpha divided by beta minus x, or it is under root x minus alpha into beta minus x. Then we are substituting x equal to alpha cos square theta plus beta sin square theta. We have to substitute this thing in that kind of integrals. Suppose here we have x minus alpha divided by x minus beta in the under root, or we have x minus alpha into x minus beta in the under root. We are substituting x equal to a sec square theta minus beta, a alpha sec square theta minus beta tan square theta in this type of integrals. Okay, and lastly integration dx divided by x minus alpha into x minus beta form. We are substituting x minus alpha equal to t square and x minus beta equals to t square, or x minus beta equal to t square. Any one of these two we are substituting, that is t. Then we can integrate that easily. So these are the substitution methods or formulas. And here we have integration by part. This is also one of the method of integrating the given function. So integration by parts is like a Leibniz rules in a ruler in the derivative, that product rule, that derivative of u into v formula, Okay, na? That u dv by dx plus v du by dx. So it is like that. Okay, the integration of f of x into g of x dx means the two functions are in multiplication and we are going to integrate that function. Okay, then the rule is called the integration by parts. The how we are integrating in this rule, that it is integration f of x into g of x dx equal to integrate this f of x as it is integrating g of x u integration of v. Okay, so we can also write this formula as like this: integration u into v dx is equal to u as it is integration of v dx, that is f of x into integration of g of x dx, minus integration whole, that is u dash means differentiating u into integration of v dx into dx plus c. U as it is integration of v minus integration of derivative of u into integration of v into dx plus c. This is u into v formula in the integration. So using this we can integrate the function which is in the multiplication. Clear? Example. For example, we are integrating this x into e power x. The one of these two we are considering u, another one is v. The integration u into v is u as it is, yani ki x as it is, integration of that is v, that is e power x dx, minus whole integration derivative of x into integration of e power x into dx into dx. Now we know that here integration of e power x is e power x, that become x into e power x, minus derivative of x is 1. The only integration of e power x remains, and we know that integration of e power x is e power x. Again integration of e power x is e power x plus c. This is our final answer. So in this way we are integrating the function which is in multiplication. Okay. Here we have a few important standard result called Bernoulli's formulas, where in this u into v method or integration by parts method. One is here integration of e power ax into sine bx. Integration of e power x into sine bx. Here this kind of integrals, the formula is e power x divided by a square plus b square, e power ax it is. Okay, na? This is what e power ax. E power ax divided by a square plus b square into a sine bx minus b cos bx plus c. This is the integration of e power x into sine bx. Okay. So using this formula in one step we can identify the answer of this kind of problem. Okay, and next there is one more formula, that is e power x into cos bx, e power ax into cos bx dx. The previous is sin bx, this one is cos bx. The formula is e power ax divided by a square plus b square, that is same as the previous formula, but here we have a cos bx plus b sin bx plus c. Previous a sin bx, here we have a cos bx minus plus there is b cos bx, we are writing b sin bx plus c. So little bit difference in the two formula. Okay, so using these two formulas we can integrate any question like this. For example, we have integration of e power 2x into sine 3x dx. I'm taking this example. Okay, na? we have a e power 2x into sine 3x dx. Here a value is 2, a value is 2. So this is a value and this is what b value. Substituting in the formula, answer become e power ax. Ax is 2x. Okay, divided by a square plus b square. 2 square plus 3 square. What is 2 square plus 3 square? 4 plus 9 is 13. So directly I'll write here 13. That is 13. Okay, into a value is 2 here. 2 into sine bx. Bx is 3x. 2 sine 3x minus b means 3 cos bx plus c. So in one step we can answer the given question using this Bernoulli's formulas. Okay, if you remember this formula, so within 30 seconds we can answer this kind of problem. So formulas are very important in this integration. Okay, so let us move to the next problem. Next concept in this. So we have some integral formulas, and I think you know all these formulas. Okay, for K, for NCERT textbook, we have around 9 formulas. This kind of 9 formulas, that is integration of 1 divided by a square minus x square is equal to 1 by 2a log a plus x divided by a minus x plus c. And the second formula is 1 divided by x square minus a square dx is 1 by 2a into log x minus a divided by x plus a plus c. If we have 1 divided by under root x square minus a square dx, then this is log of x plus under root x square minus a square plus c. If minus become plus, then here this formula is same. Inside this under root x square minus a square, we are taking x square plus a square. And 1 divided by under root a square minus x square dx is sine inverse x by a plus c. And 1 divided by a square plus x square, we don't have here under root. 1 divided by a square plus x square is 1 by a tan inverse x by a plus c. And under root x square plus a square dx is x by 2 under root x square plus a square by 2 log x plus under root x square plus a square plus c. And one more formula, under root a square minus x square dx is x by 2 under root a square minus x square plus a square by 2 sine inverse x by a plus c are the formulas. So by remembering these formulas, we can integrate. Now we are in the second part of integration, that is called definite integral. Up to here, whatever we have discussed the concept, that is what indefinite integral integrals only. Okay, and now we are starting the second part of the integration, that is definite integral. A definite integral is denoted by integration from a to b f of x dx, where a is called the lower limit and b is called the upper limit of the integral. In the integration from a to b, how we read this one? Integration from a to b. A is called the lower limit and b is called the upper limit. A and b are called the limit of the integrable function. Next, fundamental theorem of calculus means here to integrate this definite integral, we have a method called fundamental theorem of calculus. Let f be a continuous function defined on the closed interval a comma b and f be an antiderivative of f. Capital F indicate the antiderivative of the given function small f. Small f of x is given integrable function. Capital F of x is a resulting of small f of x integration. Okay, and after integration we are substituting upper value first and lower value next, and subtraction or the subtraction of upper value and lower value is the definite value of the given integrable function. For example, we have a integration from uh, 1 integration from 2 to 3 integration from 2 to 3 1 by x dx, then it is equal to, first we have to integrate this 1 by x dx. 1 by x integration is log x, and the limit is from 2 to 3. First we have to take upper value, this become log 2. In place of x we are substituting 3, that is log 3, and next minus lower value, that is log 2, and we know that log 3 minus log 2 is log 3 by 2. This is our answer. First we are integrating as normally, and we are substituting first upper value and minus lower value. Clear? That is the fundamental theorem of calculus, wherein definite integral. Next, we have some properties of definite integrals. Okay, the first property is integration from a to b f of x dx is equal to integration from a to b f of t dt. What is x here? X is a variable, so we can change the variable directly here. Suppose we have a sin x dx, then it can be written as sin t dt or sin theta d theta also. Okay, we can change the variables as usual. Next, the second property is integration from a to b f of x dx is equal to minus b to a integration from b to a f of x dx. It means that if we change the limit, if we interchange the limit of the integrable function, then the value of integration sign of integration value changes here. Suppose we have integration from a to b f of x dx value is 2, then integration from b to a f of x value become minus 2. If we interchange the limit, then the value of integration changes. Okay, changes to plus to minus or minus to plus. Next, the third property, if we have a integration from a to b f of x dx, then we can split this a to b f of x dx as a sum of two integrals. Okay, suppose we are finding the integration from 1 to 5, then we can break this integration as a sum of two integrals like this, like 1 to 3 and 3 to 5 dx. Okay, 1 to 3 and 3 to 5, like this we can break the given integration as a sum of two integrals. But whatever you are taking c that should be between the given interval a to c, a to b, in the given limit a to b only. Next, property number 4. Property number 4 is integration from minus a to plus a f of x dx. Integration from minus a to plus a f of x dx. We have two values of this function, that is, one is 2 times 0 to a f of x dx if f of minus x equal to plus f of x, or f of x is even function. Okay, and its value is 0 if f of minus x equal to minus f of x, and this kind of function is called odd function. For example, we have a f of x or integration from minus pi by 2 to plus pi by 2. Integration from minus pi by 2 to plus pi by 2 sine power 7x dx. Sine power 7x dx. So first of all we have to check whether the given function is even function or odd function. How we'll come to know the given function is even or odd? If we substitute x equal to minus x, okay, here f of x is sine power 7x. If we take x as a minus x, this become sine power 7 minus x. And you know that sine minus theta is minus sine theta, and minus power 7 is minus only, that is minus sine power 7x. This is nothing but minus f of x. This is odd function. On taking x equal to minus x, we are getting minus f of x, then it is odd function. If it is odd function, then its integral is 0. So in where in the examination this kind of problem will ask, not the first type, okay, because the value becomes 0, then we can identify its value easily, okay. Suppose in place of this sine we have cos power 7 x dx. So we know that cos minus x is plus cos x, and plus cos x power 7 is cos power 7x only. Means on taking minus f of minus x, we are getting plus f of x, that become even function. For even function, we can write this is 2 times 0 to pi by 2 and 0 to a. See that this is minus a to plus a, minus pi by 2 to plus pi by 2, that become 0 to a, that is 0 to pi by 2 cos power 7x dx. Then we have to integrate this. So this example I have taken for explaining how this can be used, this formula, okay. Exactly for getting 0, this kind of problems will be there, okay na? Exactly getting 0, this kind of problems will be there. So we can't integrate this cos power 7x directly here. So this kind of problems for even function will not be raised. Only for odd function, this kind of problems will be raised in the examination, okay. Next, we have one more property, that is integration from a to b f of x dx. It can be written as a to b f of a plus b minus x dx. F of a plus b minus x dx. For example, we have that limit is pi by 6 to pi by 3 root sin x divided by root sin x plus root cos x dx. Okay, here the sum of these two angles, pi by 6 and pi by 3, become 90 degree, pi by 2. Okay, so using this property, first we have to check whether the sum of the angle is multiple of 90 degree or not. If it is multiple of 90 degree, then you can use this formula. Okay, if it is multiple of 90 degree, then we can apply the allied angle. So that's why this property is used like this. Suppose we have a to b f of x dx, that is a plus b minus x dx. Suppose the question is like the 0 to a f of x dx, then we can write 0 plus a minus x dx. 0 plus a is only a minus x dx also. We can use this formula as this. Okay. It means if the interval is already, so sum of the interval, one is 0, already the power or upper limit is multiple of 90 degree, then we can use this property. Here the lower limit and upper limit are not multiple of 90 degree, but their sum is multiple of 90 degree. Then we are using this property. Or the lower limit is 0 and upper limit is any multiple of 90 degree angle, then we can use this formula. Okay. Next, property number 6. Here we have a integration from 0 to 2a f of x dx. 0 to 2a. 0 to 2a f of x dx. It can be here f of x plus f of 2a minus x dx. And you know here integration from 1 to 5 dx. 1 to 5 dx can be splitted as a 1 to 3 plus 3 to 5 na. If we use the splitting method, we can write this as a 0 to a f of x plus f of 2a minus x dx. Or else we can write 2 times 0 to a f of x dx if it is even function. Or on applying this 2a minus x dx, that become plus f of x. Or if we are getting f of 2a minus x is minus f of x, then its value is 0. This is property number 6. The next, now we have problems. Now we are solving the problems using these concepts. Okay. So you do one thing, this video you run very slowly and understand all these concepts, and then later you prefer to solve these problems. Okay now, let us solve the problems that we have here. Solution. We have the integration of x square plus 1. Already we have this question. We required more space, so I am not writing this question once again. You can see the degree of numerator is 2 and the degree of denominator x into x square become x cube. Then it is a proper fraction. Numerator is degree 2 and denominator degree is 3. It means it is a proper fraction. It can be integrated directly. But we have a two fractions x square minus 1. The two fractions we have in this integration. So by using a partial fraction method, we can separate these two fractions and then later we'll integrate this. Let us consider this x square plus 1 divided by x into x square minus 1. Let us this fraction separate by partial fraction method. What is the first fraction? It is x. That can be written as a divided by x. The second fraction is x square minus 1. Then its numerator is written as bx plus c. What is the degree of x? 1. Then we are taking only one alphabet. Here degree of this x square minus 1 is 2. Then we are taking two alphabets in the numerator. Suppose this power is 3. We have to write here bx square plus cx plus d. 3 alphabets in the numerator. In this way we are separating this. Next, we are finding the value of a, b and c. We will get x square plus 1 divided by x into x square minus 1. This is equal to LCM is x into x square minus 1, and the numerator is cross multiplied a into x square minus 1 plus bx into x, bx square, c into x plus cx. Both LCMs or denominators get cancelled. Resulting is this x square plus 1. X square plus 1 equals to ax square minus 1, a into x square minus 1 plus bx square plus cx. Now by comparing the LHS coefficient and RHS corresponding coefficients, we'll get a, b and c value. If we compare the coefficient of x square, if we compare the coefficient of x square here, the x square coefficient is 1 and here x square coefficient is a and here x square coefficient is b, then we will get 1 is equals to a plus b. Comparing the coefficient of x, comparing the coefficient of x, in the LHS we don't have x term. X means x power 1. We don't have x power 1 term, then LHS becomes 0. And here a into minus 1 is minus a. So here there is no x power 1 term, and here there is no x power 1 term, and we have a x power 1 term, coefficient is 0, then c value become 0. Okay, what is C value? C value is 0. If we compare constant, if we compare constant, LHS constant term is 1, and RHS, the constant term a into minus 1 is minus a. A into minus 1 is minus a. And there is no constant term here. So minus a equal to 1, this implies a equal to minus 1. A equal to minus 1, c equal to 0. Substituting a equal to minus 1 in this, and we'll get minus 1 to taking LHS, minus 1 minus plus minus 1 become plus 1, 1 plus 1 is 2, then we will get b value is equal to 2. And substituting a, b, c value where in this equation number 1, then this equation number 1 changes to x square plus 1 divided by x into x square minus 1 is equal to, what is a value? Minus 1 divided by x. And what is b value? B value is 2. B value is 2. 1 minute. B value is 2. 2 into x. That is 2 into x is 2x plus c. C value is 0 divided by x square minus 1. On integration dx, this become integration dx. Okay. Minus as it is 1 by x integration log x plus. The numerator only 2x is remaining. Denominator is x square minus 1. What is x square minus 1 derivative? 2x. That is in the numerator. Means numerator is f dash of x, denominator is f of x. Integration of f dash of x divided by f of x is log f of x. That become log f of x. F of x is x square minus 1 plus c it is. And you know log p minus log q is log p by q. So that become log x square minus 1 divided by x plus c. We are checking for this option. So there are three terms in the logarithm. Ln means it is log. Ln means it is a log. Okay. So we are checking for this option. So this option is not there. Then I will remove this and checking for the correct option here. Okay, so this can be written as minus log x plus log of x square minus 1 square can be written as x plus 1 into x minus 1. Okay, na? So this is minus log x plus log p into q is log p plus log q, that is log x minus 1 plus c. Now we will check this option in the given four options. Now we have three terms in the logarithm. Previously there was two logarithmic terms, then we have changed into 3 and checking for this option. Minus log x, in all four options we have minus log x plus log x plus 1 plus log x plus 1. Either in the first or third it is correct. Sorry, first or fourth is correct, because in the second and third both are minus. And the last one is minus log x minus 1. And but in the answer we are getting plus, it means that the fourth option is correct. Fourth option is correct. Okay, minus log x plus log x plus 1 plus log x minus 1 plus c is the correct option, and that is the fourth option. Okay, do one thing, on integrating we are getting this option. If we don't have this option in the given four options, let us try to change the given answer, resulting answer. Whatever we got, that answer, can we change that answer into any one of these four options? So if it is possible, then change it and check the correct option. Clear? Let us move to the next problem. The second question, integration from 0 to 1, 1 divided by 1 plus x square. You can see that here we have 0 to 1 limit, 0 to 1 limit we have, it means that this is a definite integral problem. Previous question, there is no interval, there is no limit, then that is a indefinite, that is indefinite problem, and this is definite integral problem it is. Okay, let us integrate this. 0 to 4 dx divided by 1 plus x square is equal to, we know that 1 divided by 1 plus x square integration is tan inverse x. What is the integration of 1 divided by 1 plus x square? Tan inverse x. Okay, and what is the limit here? 0 to 1 it is, 0 to 1. That is 0 to 1. First we are taking upper value, that become tan inverse 1 minus lower value we are taking, that is tan inverse 0. In tan, when we will get 1 value? At pi by 4. And at tan, in tan, when we will get 0 value? That is at 0. Pi by 4 minus 0 is pi by 4. Our answer is pi by 4. That is, the first option is correct. Clear? In this way, we are solving the problems. Now, integration of cos square x dx, and the limit is from 0 to pi by 4. We are finding its value. Okay, cos square x integration. Integration from 0 to pi by 4 cos square x dx. We can't integrate this cos square x directly. We can't integrate this. We have to substitute identity, trigonometric identity, that is cos square x is equal to 1 plus cos 2x divided by 2. On using that, it becomes 0 to pi by 4, that 1 by 2 can be divided by 2 can be written outside, remaining is 1 plus cos 2x. This can be integrated directly here. Okay, then what is the integration of 1? Integration of 1 is x, and cos 2x integration is plus sin 2x divided by 2, and the limit is from 0 to pi by 2. 1 integration is x, and cos 2x integration sin 2x by 2. Let us substitute upper value, 1 by 2 outside as it is, that x is pi by 2 plus if you take x as pi by 2, that become 2 pi by 2. 2 cancel, pi remains, and sin pi value is 0. This is upper value minus lower value. On taking x equal to 0, this becomes 0 minus taking x equal to 0, sin 2 into 0 is 0, sin 0 degree value is 0. The only pi by 2 is remaining in the bracket. Yes. So that become 1 by 2 into pi by 2 is pi by 4. Pi by 4, pi by 4, pi by 4. Na? This is pi by 4. Integration from 0 to pi by 4 it is. This is pi by 4. Then this become pi by 8. The remaining all are 0. Completely it is 0. So our answer is pi by 8. What is our answer? Pi by 8. Checking for this option, we don't have this option, because the first option is pi by 4 plus 1 by 4, pi by 4, but that is pi by 8. No, pi by 8 we have, but 1 plus 1 by 4 we have extra term, then that we don't have here. Here minus 1 by 4 we don't have this term. Then the none of this is the answer. Clear? So in this way we are solving this kind of problem. We'll continue in the next class. So you run this video very slowly and understand the concept, how to integrate this, and try to solve this kind of more problems, okay, yourself. Then definitely you will get good marks in the CUET examination. So, in the next class we will continue with the more problems. Okay students, thank you.